Here we're asked to determine the intercepts of the given function. We are given f of x equals -2 times the absolute value of the quantity x plus 1 plus 3. Remember, whenever given a function, we can always replace f of x with y. And now let's look at our notes below. We find the intercepts of any function using the same method. To find the x-intercepts, or horizontal intercepts, we set y or f of x equal to 0 and solve for x. And to find the y-intercept, or vertical intercept, we set x equal to 0 and solve for y. Let's begin by determining the x-intercepts by setting f of x or y equal to 0. This gives us the absolute value equation 0 equals -2 times the absolute value of the quantity x plus 1 plus 3. To solve an absolute value equation, we first isolate the absolute value. Our next step is to subtract 3 on both sides of the equation. Simplifying, we have -3 equals -2 times the absolute value of the quantity x plus 1. And now we divide both sides by -2. Simplifying, we have 3/2 equals the absolute value of the quantity x plus 1. I do want to mention here, if the absolute value is equal to a negative value, the function would not have any x-intercepts. In this case, though, we have the absolute value of the quantity x plus 1 equals 3/2. Remember, the expression inside the absolute value can be positive 3/2 or negative 3/2, and then when we take the absolute value, it would give us positive 3/2. This indicates we have to set up and solve two equations, where one equation is x plus 1 equals 3/2, the other equation is x plus 1 equals -3/2. And now I solve these two equations for x. Starting on the left, we subtract 1 on both sides to solve for x. 3/2 minus 1, or 3/2 minus 2/2, is equal to 1/2, giving us x equals 1/2. And then for the second equation, again, we subtract 1 on both sides, but we have -3/2 minus 1, or -3/2 minus 2/2, which equals -5/2. So we have x equals 1/2, or x equals -5/2. Now remember, we're finding the intercepts of the graph, which are points on the graph. So we need to give the intercepts as ordered pairs. The x-intercepts are 1/2, 0, or 0.5, 0, and -5/2, 0, or -2.5, 0. And now let's determine the y-intercept, or vertical intercept. To do this, we set x equal to 0, or determine f of 0. Using the equation with y, we have y equals -2 times the absolute value of the quantity 0 plus 1 plus 3. Simplifying inside the absolute value, we have the absolute value of 1. Of course, the absolute value of 1 is 1, and therefore we have y equals -2 times 1 plus 3, which is -2 plus 3, or positive 1. This indicates the vertical intercept is the ordered pair 0, 1. Before we go, let's check this graphically using Desmos.com. You can see on the left I entered the function y equals -2 times the absolute value of the quantity x plus 1 plus 3, which is graphed on the right. Checking the x-intercepts first, we have -2.5, 0, or -5/2, 0, as well as 0.5, 0, or 1/2, 0. And here we see the y-intercept, or vertical intercept, of 0, 1, verifying our work is correct. I hope you found this helpful.